This next one is for you folks to try. It's an even numbered problem from the textbook. I didn't choose an assigned homework problem just because there's not actually that much homework assigned for this. We're nearing the end of the semester. I'm trying to keep the homework not too onerous so that if any of you are playing catch up, you have a little bit of a chance to do that. But because I didn't assign all that much homework, I want to make sure that I'm keeping that for you to practice on your own afterwards. So give this even numbered one a shot, pause the video, work it out, and then tune back in and we'll go through it together. Before I had you pause the video, I forgot to mention that I was thinking we would do this one using the addition method. I think it's nicely set up for that because both equations have the same three types of terms, x squareds, y squareds, and numbers. It would be possible to do it by substitution, not actually solving for x or y, but I could solve for x squared or y squared and substitute that in. Okay. But I think this one is set up a little bit more nicely for the addition method, so let's do that. Now, if I look, I don't have the opposite number of x squareds, and I don't have the opposite number of y squareds. And the number of x squareds that I have in the two equations aren't multiples of each other. Same thing for the y squareds. So if I don't want to introduce fractions, I'm going to have to change both equations. That's okay, I can do that. I think I'm going to try to get to the opposite number of y squareds for two reasons. One, I already have opposite signs. Two, the absolute value of those coefficients, 5 and 3, is a little bit smaller than the 6 and 7 that I have here. Okay, so I'm going to multiply this first equation by 3. Now remember, that means every single term gets multiplied by 3. So that's 18x squared plus 15y squared is going to equal 38 times 3, which I'll work out off to the side here, 114. All right, let's multiply this second equation by 5. That way we'll have 35x squared plus 15y squared is equal to 45. So now we successfully have, whoops, I'm sorry, I said minus, I think, but I wrote a plus sign there. This should be a minus. Okay. So now we do have the opposite number of y squareds. If I add the two sides together, I'm going to have 53x squared is equal to 159. Okay. Now, if I divide both sides by 53, x squared is just 3. 53 goes very nicely into 159. Okay. So I can now solve for x. Remember, though, I'm going to have two options. X is plus or minus root 3. And for each of those x values, I need to find its partner, the corresponding y value. Okay, so if x is positive root 3, now I can use either equation here. I think I'm going to go with this second one and just avoid the 38 because that's kind of big. So 7x squared minus 3y squared equals 9. Okay, that's 7 times root 3 squared minus 3y squared equals 9. Root 3 squared is just 3. So 7 times 3 will be 21 minus 3y squared is equal to 9. I'm going to subtract over that 21. So negative 3y squared is equal to negative 12. Divide through by negative 3. And I've got that y squared is 4. Now that means that y is plus or minus 2. I get two answers in that case, and both of those go with x being root 3. Okay. So just listing my answers here, I've got root 3, 2, root 3, negative 2. That's two solutions right there. I still have to check my other x value. Okay, so let's do that. if x is negative root 3? You might notice I should be getting the same two y values because all I'm going to do with x is square it, and root 3 and negative root 3 squared to be the same thing. But let's actually work it out. So it was 7x squared minus 3y squared is equal to 9. So that's 7 times negative root 3 squared minus 3y squared equals 9. The negative sign goes away when I square it. So this just becomes 3 times 7. So that's 21 minus 3y squared equals 9. We've seen this before. So negative 3y squared is negative 12. Y squared is 4. And y is plus or minus 2. So these two y values go with that x value as well. So I also have negative root 3, 2, and negative root 3, negative 2. So a total of 4 solutions that we get in this particular case. So notice we don't know ahead of time how many solutions we should be getting. Okay. So one important consequence of that is if I don't know ahead of time how many solutions I'm going to get, if I happen to see something that works and I prove that it works, that's not the same as solving the system. I've maybe found one point that works, but I don't know that I found all of them unless I actually work through the algebra. Okay. Again, although it's not required, it can be reasonable to just plug in and make sure that we've got solutions to the second equation as well. So, root 3 and 2, if I were to square root 3, I would get 3 times 6 would be 18. Y squared, 2 squared would be 4 times 5 is 20. 18 plus 20 is 38. And because it was x squared and y squared that showed up here, all these other points are going to check as well, because all of my x values square to give me 3, and all of my y values square to give me 4.